Good day, everybody. Okay, we're starting 7.4 confidence intervals. This is going to be quite a lengthy video, but again, you only need to do this or stay at the top of it if you are going to take statistics in university. If not, don't worry about it. Okay, so a bunch of this is just information, then we'll get to the questions. So margin of error, you guys can read the definition here. Okay, so what happens is when you do an experiment, you get your results and you have your scores, your z-scores, your standard deviation and such. But we want to know how accurate is the results. So with any survey or experiment, stuff like that, we have some error. Okay, so just error is going to happen within your results. So we calculate the margin of error. So they'll give you a range of values. I'll show you that with an example. So we have E, which is the margin of error. We have Z, which is your z-score. Okay, P is probability. Sorry, not probability, percent. Percent as a decimal. Okay, N is the total number. So E, margin of error, Z is your z-score, P is a percent as a decimal, and N is your total number. Okay, so these three letters are the same. Okay, then we have a confidence level that just tells you how confident are you in your results. Okay, so whenever you have a confidence level here, you're going to go to this chart and you are going to take out these this information. So in our textbook, if I could grab it 1 second, they don't have all these four, they have 3 out of the 4. So I'm going to pull the textbook. So the textbook has the chart on page 353. So they have this one here. So they have the 90%, 95, and 99. Minus has an extra one, which you won't use. So you'll be using these confidence level scores. Okay, so everyone says, what is the, say, 95th? They want the confidence level to 95%. You go to the chart and you get your z-score. Okay, so your z-score. This is confidence interval here. It shouldn't be interval. This should be level, confidence level. Okay, then we have confidence interval. Okay, this is the range of possible values. So it's an interval. Okay, so an interval gives you a range. So we have a range of values. So what's the lowest value and what would be the highest value? Okay, so where all of our values would lie. Okay, so we have percent. So if you're given, there's 2 different ones you can do for confidence interval. It depends on what is given. So if you're given the percentages, we're going to take the percent and we're going to add and subtract the margin of error. But if you're giving values, if values are given, then we're going to use this one here. Okay, so we're going to take our X bar. So on your notes, please correct this. This should be X bar, which is our mean. And we're going to add and subtract our standard error. Okay, or our margin of error. Okay, don't worry about this one here. I'll cross this one out, we won't be using it. Okay, so, and then we have to find your E, your standard error, we use this formula here, which is our z-score times our standard deviation divided by our total, square root of our total numbers. Okay, and then lastly, we have something, a repeat sample. So if we're repeating our samples, we could actually use some previous information. So when you ever see this, so you've previous sample to help the current one. So we have the standard deviation of the average, so standard deviation divided by the square root of the total numbers. This here, you're going to use, this gives you the standard deviation for the sample means. Whenever you see this sample means, you're going to use this formula here. Okay, so the keywords here, sample means, you're going to use this formula here. Okay, let's go to number 1. An opinion poll surveyed 100 households who were watching television at a particular time. Of these, 75% were watching Hockey Night in Canada. Determine the margin of error at 99% confidence level. Okay, so what I would do for at this point here, guys, since we're going to have multiple formulas, we have multiple formulas here, what I would suggest you do is list out what you have. And once you list out what you have and what you need to find, then that will help you pick out the formula you need to use. Okay, so we're looking for margin of error. So we're looking for E. Okay, and then what is given to us? Well, 100 households would be the total number, so that would be our N value. So 100. Then we have 75% Hockey Night in Canada, so 75% would give us our P. So percent is a decimal, so that's our P, which is 0.75. Okay, and then we say at 99% confidence level, so we can't use this as it is. We can't use this 99%, but this helps us get some other information. So the 99% tells us our Z-score. So we go up to the table, and our Z-score for 99 will be 2.576. Okay, so we have a Z, we have an N, we have a P, and we're looking for E. So that tells us we need to use this formula here. So Z, P, and N. Okay, so let's substitute the values in. So E equals Z P1 minus P over N. Make sure that this whole fraction is underneath the square root sign. So our Z-score, 2.576. Our percent is 0.75. And if you do 1 minus 0.75, you get 0.25. All over our N value, which is 100. Okay, so I'm just going to skip some steps here. So if you answer all this and square root it, you get 0.0433, which gives you the answer 0.112 or 11.2%. Okay, so with this information given, so out of 100 households, they're saying 75% of the 100 households would be watching Hockey Night in Canada. So they're saying 75 out of 100 would be watching this station. But there is some errors within this information. So to be confident, so you want to say that 99% of the time this is going to occur, there's going to be some error. So what this saying is, well, this could be true, this 75%, but there's an error of 11%. So that means this value of 75% could be 11% lower or 11% higher. Okay, so it's going to lead us to our next question here, which is determine the confidence interval. So interval for the situation. So we're going back to the interval here. So we are looking at here. So if we're given percent, we're going to add the margin of error, plus or minus. If we're giving a value, then we're going to use this formula here. But in our question, we are given a percentage. So we're going to use the first one. Okay, so we need an interval. So that's a range of values. So we're going to find the lower range, and then we're going to find the higher range. Okay, so here, so percent plus the margin of error, and then the percent minus the margin of error. So our percent here is 75%, and we are going to subtract. We're going to subtract our margin of error, which is 11.2. And then we're going to take the 75%, and we're going to add 11.2%. So 75 minus 11.2 would give us 63.8%. And if we add it we'll get 86.2%. Okay, so the range or the interval is from 63.8% up to 68.2%. Okay, so you can round it. If you said 64 to 86, that would be fine as well. So, okay, so I'm going to explain what this means. So how would a news source state the results? Okay, so Hockey Night is watched by 75% of households. And this estimate is considered correct within plus or minus 11.2%, 99 times out of 100. Okay, so I'll tell you what this means. Okay, so the original question said that 75% of households are watching Hockey Night in Canada. Okay, so if you want to take the information and kind of dissect it. Okay, so we're saying here is it's watched by 75% of households. Okay, but this information is not 100% correct. It has some errors to the question because we only asked 100 households. We didn't ask every single household to get an accurate information. We took a sample. Okay, we sampled 100. So there's going to be some errors within our information or our answer. So using the 99 percentile or confidence level, we found that this information is correct, but it's with an error of 11.2%. So what that means is if you were to do this survey again, you would most likely get an answer in between these two percentages. So if you asked another 100 households, you would have between 64% and 86% of households watching Hockey Night in Canada. Okay, and then we say that is true 99 times out of 100. So the 99 is from our confidence level. Okay, so 99%. So that means if you were to do this survey 100 times, 99% of the times, your range will be in between these two values, which means that one time out of 100, it might be higher or lower. Okay, so 75% of households, this would be correct with 11% margin of error. So above or below 99% of 100. Okay, so just to let you know how this works is if we picked a different confidence level, say 90%, then your range will probably be a little bit lower, but it would only be true, say 90 times out of 100. Okay, so now to part 2. Fixing my hair. Okay, so the next one is a pharmaceutical manufacturer makes more than 500,000 pills of a certain drug each day. The company randomly samples 400 pills daily to check that they meet the proper weight and size standards. On a given day, 52 pills were found to be substandard. Okay, so this happens to any kind of company, and especially ones that are mass producing items. They'll be, if it's going through machines, sometimes the product is not exactly what it should be. So the companies hire people to go in and just check random amounts. So in this case, pills. So they make 500,000, but they go and take 400, and they would see how accurate or how good are these pills. It's just kind of a quality control check. Okay, this happens all the time. Okay, so on this given day, out of the 452 were to be substandard. That's actually quite a large number. Okay, so we're going to do some questionnaire. So that'd be a lot 52 out of 40, that's quite a lot of errors. Okay, so what is the margin of error? So we're looking for E. Okay, so we're looking for E for this sample at a confidence level of 90%. So confidence level at 90%. Again, that's we get our Z score. So we're gonna have a Z score of 1.645. Okay, so we have a Z, we have an E. So now we gotta kind of determine which formula we're going to be using. Nextly, we have 500,000 pills, 400 pills, and 52 pills. Okay, so we could get a percent, where a percent is not given, but we can get it from this information. So given on the quality control check, we have 52 out of 400. Okay, so our percent, if you hear my baby girl in the background, she's crying a little bit. So our percent, 52 out of 400. Okay, will give us our percentage of how many are substandard. Let's get my calculator here. So we have 52 divided by 400 gives us 13%. So our percent is 0.13. Okay, so we want margin of error again. So we're looking for our E value. So we have our Z, we have our P, and our N is not 500,000. Our N will be 400. So our Z 1.645. 0.13, and then remember 1 minus 0.13 is 0.87 over 400. Okay, so now if you work this out, you get 1.645. If you multiply, divide, and then square root, you get 0.0168. which is 0.028 or 2.8%. Okay, so with this information here, so 13% of the pills will be are substandard, so that would be true. The margin of error would be 2.8%. So it'd be 2.8% higher and lower than this. So that's roughly from 10% to 15%, or sorry, from 10 to 16. Okay, so for what range of percents can you be 90% confident that the pills will be the right size? Okay, so this one's a little bit, be careful when it's asking. So this says the right size. Okay, so we want the right size here. This percent, this percent here is for the wrong size. So we have 87% would be the correct size, but now we want to know how confident, for what range. So remember, the range is for confidence level. So we range a confidence level. So we're going to add and subtract our answer to this one. So at the lower level and at the higher level. So our lower level would be 87 subtract 2.8, and at our higher level would be 87 plus 2.8. So it gives us 89.8%. Oops, sorry, that's not correct. That's for this one. Okay, and for this one, it would be 84.2%. Okay, so this would be, the range would go from 84.2 and 89.8%. Okay, so that means if they were to take another 400 pills tomorrow, you would probably get a range of 84 to 89% would be the correct size. Okay, I'm just going to pause this video here and then start it up just so it doesn't take so long to upload on YouTube.